What if everything we thought we knew about the universe's beginning was wrong? The James Webb Telescope just sent back data so shocking, it's shaking the foundations of the Big Bang Theory itself. The inexplicable discoveries made by the James Webb Telescope have left astronomers completely baffled. Instead of deepening our knowledge of the universe, Webb's findings reveal a disturbing fact. Our understanding of cosmology is simply not sufficient to explain the nature of the early universe. Where the tried and tested Big Bang Theory has clearly had its day, new theories of creation must be developed. But why is this once sacrosanct idea now coming under increasing criticism? And above all, what is the alternative to the Big Bang? Stay tuned until the end and join us as we get to the bottom of this fascinating topic. Even those who are not particularly interested in astronomical research know that everything began with the Big Bang. But what does that actually mean? How did the birth of the cosmos unfold in detail? And how can we even know this so many billions of years later? Contrary to initial assumptions and some descriptions, the Big Bang was not an explosion into an existing space, but rather space itself, which emerged around 13.8 billion years ago, together with time and matter from an original singularity. This singularity in turn describes a point or state of infinite density, temperature, and space-time curvature, and thus a place where the known physical laws of general relativity reach their limits. When it comes to the question of how we can know this today, experts point to a characteristic that the universe has possessed since its inception: it is expanding. Ultimately, however, this discovery is still relatively recent. Less than a century ago, Edwin Hubble proved that the Milky Way is not the only galaxy in the cosmos, and that the other galaxies are actually moving away from us. The cosmological worldview of an unchanging and eternal universe was thus overturned practically overnight. But again, it is not the cosmos expanding into an existing space, but space itself that is growing larger. What all this has to do with the Big Bang becomes clear when we look at this process in reverse, allowing experts to calculate backwards to a point of infinite density and zero spatial distances, reaching the cosmic starting point. The proof of cosmic microwave background radiation is considered outstanding evidence for the correctness of the Big Bang Theory. This is a remnant of radiation that originated about 380,000 years after the Big Bang, during the recombination epoch, and still fills the entire universe today. However, it should be noted that the Big Bang Theory does not explicitly deal with the actual birth of the universe, but with the immediate phase after it, specifically from Planck time, 10 to the power of -43 seconds, to 400,000 years after the Big Bang. And although we have no idea what the universe looked like before Planck time, the Big Bang Theory remains central to the standard model of cosmology. This makes things more complicated when researchers discover something that simply cannot be reconciled with current models and causes some to question everything we thought we knew about the universe's origin. According to conventional wisdom, the first stars formed about 200 to 300 million years after the Big Bang, ending the so-called Dark Age. However, when the James Webb Telescope detected galaxies just 300 million years after the Big Bang, scientists were intrigued. These galaxies were small and less massive, as expected, until 6 reddish points of light were found, which turned out to be galaxies nearly as massive as the Milky Way. These shouldn't have existed so early. Scientists at Swinburne University of Technology in Melbourne initially suspected a mistake, but follow-up data confirmed that some of these galaxies already contained over 10 billion stars, one even exceeding 100 billion. This directly contradicted our theories, which claimed there wasn't enough normal matter at that time to form so many stars. These galaxies earned the nickname universe breakers because they challenged the very foundation of cosmology. To explain their existence, either the matter density was 5 times greater than we thought, or the galaxies formed in an unknown way. But this was just the beginning. The discovery of the universe breakers led to a series of similarly puzzling findings by Webb that suggest something is deeply flawed in the standard cosmological model. Webb also found supermassive black holes and chemical elements far earlier than expected and confirmed the Hubble tension. The universe is expanding faster than predicted. Some researchers now believe the universe may not have originated with the Big Bang. Even supporters of the Big Bang admit it leaves many unanswered questions. How did something emerge from nothing? Was there a trigger? Stephen Hawking famously said asking what came before the Big Bang is like asking what is north of the North Pole. Time began with the Big Bang, so nothing came before. Still, the mystery of the universe's uniform radiation and matter density remains. Cosmic inflation theory proposes a phase of rapid expansion fractions of a second after the Big Bang to explain this, but it's controversial. Alternatives include chaotic inflation, suggesting endless bubble universes, each with its own laws of physics. Our universe could be just one tiny part of an eternal multiverse. Another theory, the Big Bounce, proposes that our universe came from the collapse of a previous one, in an eternal cycle of birth and rebirth. There's also the steady-state theory, which claims the universe has always existed and matter continuously forms, giving the illusion of expansion. Perhaps the most radical theory stems from quantum physics and string theory. The universe might be a flat hologram projected onto a sphere. In this view, we and everything we perceive are part of a higher-level simulation, possibly created by an advanced civilization. A Type 3 civilization on the Kardashev scale, using a Matryoshka brain to simulate reality. Whether we'd even want to know the truth about that possibility is another question entirely. Hit that subscribe button, share your thoughts below, and let's keep exploring the together. Thanks for watching, and we'll see you in the next.